Still on the mission of you succeeding to make sure that you get your examination, you score about 90 or 90 and above in your physics in your JAMB. So today we're going to be considering the following. First of all, we're going to be considering the topic that is called light energy. And in this light energy, you expected to learn the following. The following things you're going to be learning are, the things you're going to be learning are, you have to understand or compare the natural and artificial source of light. Then number 2, differentiate between luminous and non-luminous objects. And number 3, relate the speed, frequency and wavelength of light. And also the last one has to do with interpret the various formation of shadows and eclipse of pinhole camera. So in this class, you normally know how we normally do it. Now I am not here to explain or teach you like your regular teacher, and I'm here to just expose you or make you understand things you expected to know to be able to answer any question that comes up in your JAMB on your work. You know, these examinations are very, very simple. But okay, before we move on, if you are new to this channel, please subscribe and also click on the notification bell icon to know when I upload a new video now. So without wasting much of your time, let's get started. So before we proceed, there's something that I need you to understand. First of all, what is this light energy? I'm not going to be defining what light energy is all about now, but you need to understand one thing. Now, this light energy is from the family of electromagnetic wave. Is a part from the family of electromagnetic wave. You remember that we have what we call mechanical wave. We also have what we call electromagnetic wave. Now, electromagnetic wave are those waves that do not require what? Electromagnetic wave. Electromagnetic wave. So electromagnetic wave are those waves that does not what? Wave. That's okay. Does not require what? Material medium for their propagation. Material medium for it to carry them for their propagation. They don't require what? Material medium, and that is what we call the electromagnetic wave. So an electromagnetic wave, now the best way to remember electromagnetic wave that we have is by the use of this short form or this mnemonic called Gazule. So this is the best way I remember this. This is your U, this is Gazule. And what does that actually mean? It just simply means what now? Your GA simply means your gamma rays. So your GA means your gamma rays. So when you talk about that, that is your gamma rays. Your X means what? Your X rays. Your X rays. Then your U means your U means your what? Your ultraviolet ray. Ultraviolet. Sorry, this is ultraviolet what? Rays. Then your L means your what? Your light wave. Your light wave. So light wave. Your I means your what? Your infrared. So I means infrared. Okay, and your R means your what? Your radio waves. Your radio wave. So this is exactly what we have. Now you now see that this light energy that we're about to consider, or this light wave we're about to consider, is under the family of the electromagnetic wave, and you can now see where it belongs. You can now see where it belongs. So we are going to be talking about this. Out of this wave that we have, light is the only one that is visible. You know, light is also visible to the eye. Unlike other electromagnetic waves, they are not visible. Gamma ray is not visible to the eye. The X-ray is not visible to the eye. The ultraviolet ray is not visible. Infrared and radio wave, they are not visible to the eye. The only one that is visible to the eye is the light wave, which is the one we normally see around us during the day. You look at someone, you're able to see the person. During the night, you turn on your light, you're able to see something. So this light wave is the only wave, electromagnetic wave that is visible to the eye, unlike others now. So we're going to consider what you call these sources of this light. Let's talk about the sources of light, which is the next thing that we're going to consider. Now we have two sources. So let's consider, we're going to consider what you call the sources of light. Sources of light. So we have what we call the two sources of light. One, we have what we call the natural source. We have what we call the natural source of light. And number 2, we also have what we call the artificial source of light. So we have two sources of light, natural source and the artificial source. Now, the natural source of light is just the one that is made by nature. It is not man-made. And this natural source of light includes the following. So remember what I just said. I said that natural source of light is the one that is made by what? By nature. And our examples of our natural source of light includes your sun, please don't be tempted to say that moon is also included. Moon does not give out light. Moon is not a part of it, though you might see light from moon, but moon is like a mirror. Like moon reflects this the light from sun to the earth. So moon is not an example of natural source of light. It doesn't give light. So just bear it in mind that we have sun. Then we have something like some ant like your fireflies that give out lights. So we have fireflies. We also have something like your stars. We also have stars. Then we also have the glowing worms. We have glowing worms, and we also have what you call the incandescent. So these are examples of what we call the natural source of light. So these ones, they give out light. They are they give out light, but they are not being made by man. They are made by nature. Now, coming to the next one, that we have what we call the artificial source of light. The artificial source of light is made by man. So the source of light that is made by man that you always see around you is what you call the artificial source of light now. And these include, first of all, we have your matches. Whenever you strike your matches, you're going to see light. You're going to see light out of it. That one is made by man. And another one is what you call your torchlights. Another one is your torchlight. Whenever you get your torchlight, you turn it on, you see light coming out, and it's also made by man. Then another is what you call the electric lamps. Then apart from electric lamp, we also have what you call the car headlamps. Lamps. Then aside this source of light that we're talking about now, then we need to talk about what we call luminous objects and the non-luminous objects. Luminous objects, meaning that these objects, they give out light themselves, whereas the non-luminous objects, they don't give out light, rather they do what they reflect that light. So we're going to consider what we call the luminous and the non-luminous words. So let's talk about what we call the luminous objects. We have what we call the luminous objects. We have the luminous objects, and we're going to talk about what we call the non-luminous objects. Non-luminous objects. So we have what we call the luminous objects. We also have what we call the non-luminous objects. And what exactly did I say that luminous object is all about now? Now, luminous objects are those objects or those sources of light that produces light by themselves. And examples of luminous objects are, let me just give an examples. They are just tell them, don't know that the examples are the example. It's all the examples of our natural source of light. All the examples of natural source of light. Please, if you do not remember what I said about examples of natural source of light, take this video a little bit back, or you see where I gave an example of natural source of light, natural source, and all the examples of what we call the artificial source of light, artificial source. So all the examples, remember the examples of natural source when I was talking about the sun, the fireflies, and so on, And this one, I was talking about torch lights, car headlamp, and so on, headlamp, and so on, headlamp, and so on. So if you actually want to get some more examples, please just take this video a bit backward to see where I gave. So the examples that I gave under natural source of light and the examples that I gave under artificial source of light are all included onto what you call, they are called the luminous objects, because they give out light, they produce light. They give out light, and like they produce light. Then when you come to non-luminous objects, these objects, they don't produce light. What exactly do they do? Now they reflect that light. So whenever light falls on them, they reflect that light. And examples of those ones include examples. We have what you call your moon. I told you before that moon is not an example of luminous object. It doesn't give out light. Rather, it reflects lights. So we have examples like moon. Then we have other examples like we have example like Earth. We have moon. The Earth. We have Earth. We have road sign. We have something like your road signs. Road sign. Okay, road signs. We have road signs. We have pages of your textbooks. Pages of textbooks. It looks like I'm going too far. Let me give you further examples now. Like the way you are seeing, you are able to see me because light falls on me, and the light that falls on me is being reflected to the camera. Likewise, so if you look at me now, I myself that is giving you an example, I am an example of non-luminous object. Rather, what happened to me is light falls on me and you are not seeing me on camera. Assuming there is no light now, I am not going to give a light. Probably you will not see me. Likewise, this board that I'm also using to teach now, you are able to see everything that I wrote because light falls on it, and the light that falls on it is being reflected to the camera, and that is why you're able to see all this that I'm writing. If the light goes off, now you will not see all those things now. So this is how to know the examples of what you call the non-luminous objects. They are not far-fetched. They are the things that are around you. You know, the examiner expects you to understand all these things instead of you cramming them. It's only when you understand all these things that will make them, any way they present the question, you'll be able to answer them. So when you look at it now, I've given examples of non-luminous objects as your Earth, your root signs, your pages of your textbooks. You can also give examples and most objects around. In fact, any object that is around you, most objects, any object that is around you that you can see, that is not producing light itself, rather you can just see it in the day. If I have to know the one that belongs to non-luminous object, is very simple. Any object that whenever it's in the dark, you're not going to see light from it, like you're not going to see them, it's under what we call the non-luminous object S. Now, since we've already talked about it, now let's talk about what we call the propagation of light. Now, under this propagation of light, now we're expected to talk about what we call the frequency, the wavelength, and the speed of light. So these are the features that we're supposed to talk about. It's one of the objectives that we're supposed to cover, or that we're going to cover. So let's look at what we call the propagation of light. Let's look at so under propagation of light, propagation of light. You have to take note of the following. Propagation of lights. Okay, first of all, now in relation, so we're going to talk about propagation of light. First of all, we're going to talk about propagation of light in relation to what we call to your speed, your wavelength, and frequency. So what exactly are we going to have? Let's start with in relation to speed, wavelength, and frequency. Number one point that you need to take note of is that, number one, light wave, take note of this point. Please take note of this point, that light wave has a shorter wavelength. It has a shorter wavelength, higher frequency, and greater speed, and greater speed, and greater speed, and greater speed, and greater speed in air than sound wave. Please, I need you to take note of one thing. Now, I just said that light has a shorter wavelength, but before then, how do you know the wavelength of, how did I know that, or how can I recall that it has a shorter wavelength and higher frequency? Let me show you how to recall, in case if you come to the exam, you don't need to cram this, you need to do something to recall. Now, first, remember that light is among the family of the gazelle that I wrote before. You know, this is gazelle. This is a short form of what we call electromagnetic wave. Now, coming to this end, if you come to this end now, this place now has the shortest wavelengths. This place has shortest wavelengths, and the highest frequency. Highest what? Frequency. Just take note of this. Then coming to this end is going to be what now? The longest wavelength, and what we call what now? The shortest frequency. So what exactly do we mean by that now? If you look at this now, what exactly it means that if you are going from here to here, if you are going from your gamma to your X-ray now, that your gamma ray has the longest wavelength and the shortest frequency, followed by this. So this person has the shortest wavelength. So this has the least wavelength, the shortest wavelength, and also this has the highest the highest frequency. So if you look at this now, we can now classify. You can now see that from this now, you see that light ray has what you call is under the shortest. So that's why I say it has a shorter wavelength, though not the shortest, but it has a shorter wavelength and high, not the highest, higher frequency, which means that the frequency of light wave is higher than all these ones that are here. So it's like I said before, if you're going towards this direction now, what happens now? The wavelength does what now? Becomes shorter, and also the frequency does what? Increases. So if you're going this way, wavelength decreases, wavelength what? Decreases, while frequency does what now? Increases. The frequency increases if you're going towards this direction. So this is one of the points that you need to take note of. Now the next thing we're going to talk about is that light wave is visible but sound is not. So the next point is this now. Okay, the next point is what? Light wave. Light wave is what? Light wave is visible. Light wave, like I said before, light wave is also visible. It's very, very visible. So light wave is visible, and while sound wave is not. Then another feature that you need to know is that light wave is what we call, light wave is transverse. All electromagnetic wave are transverse. So light wave is what? Transverse, while sound wave is longitudinal. So longitudinal. But one thing you must take note of is that, what did I say now? I said that light wave is transverse, all electromagnetic wave. So which means your gamma, your X-ray, your ultraviolet, your light, your infrared, and your radio wave, all of them are what? Transverse. So the method of propagation is always transverse. So all light wave is transverse, then while sound wave is what? Longitudinal. So that is it now. So the next thing we're going to talk about is what you call the formation under propagation of light. The next one is what you call, number 2 is what you call formation of what now? Of shadows and what you call what now? Eclipse. So let's talk about shadows, formation of shadows, eclipse, and images on the pinhole camera is one of the things that I'm going to be mentioning now. But in actual sense, talking about formation of shadows, eclipse, and so on, now there's one thing that you must say now, you must know now, there's what you call rectilinear propagation of light. Under propagation of light, now there's what you call rectilinear propagation of light. Rectilinear propagation. Please take note of this. It's very important. Propagation of what? Of light. And what does this rectilinear propagation of light mean? It just simply means that it's trying to make you understand that light travels in what we call a straight line. So anytime something blocks it, and to prove it now, the only phenomena that shows that light travels in straight line are one. The only thing that shows, or phenomena that show that light travels in a straight line are one. We have shadows. So another one is what you call the eclipse. Another one is what you call the pinhole camera. Camera. So these are the three things that proves or that shows that light travels in what? In straight line, or yes, it travels in what you call straight line. So please take note of this. So if your examiner gives you that what phenomena shows that light travels in straight line, the phenomena that shows that light travels in straight line are shadows, eclipse, and what? The pinhole camera. So these are the phenomena that shows now. So I'm going to be talking about these three things now. So which is the shadows, eclipse, and the pinhole camera. So let me start with what you call shadow. Let's start from what you call shadow. So shadow is formed when an opaque object blocks the light. So when the light is being blocked by an opaque object. So when light is blocked by an opaque what? Object, a shadow is being formed. Remember, I just said the word opaque objects. There are other objects that we have. Opaque objects are those objects that doesn't allow light to pass through them. Aside opaque objects, we also have what we call the translucent translucent objects. Those objects that allows light to partially pass through them. We also have what we call the transparent objects. So the transparent objects are those objects that allows light to pass through them. So but for this one, for you to get your shadow, the object you're going to use is what you call the opaque object. They doesn't allow light to pass through them now. All right, under this shadow now, we have two types of shadow. This shadow can be what we call, we have what we call the umbra shadow. We also have what we call what? The penumbra what? Umbra shadow. So this shadow can be classified into two. We have what we call the umbra shadow, and we have what we call what now? The penumbra shadow now. So in umbra shadow now, we are going to have what we call total darkness. So this is where the source of or the opaque object blocks the light, blocks the source of light completely. So this is not partially. So what is umbra shadow? The umbra shadow. What is umbra shadow? Umbra shadow is where light, the light is being blocked by the opaque object completely. So when light is completely blocked by an opaque objects. Let's remove this. Opaque objects. That will result to what you call umbra shadow. It will form what you call the umbra shadow. And the only way it forms is that when the source of light is very small. So whenever you have the source of light to be small now, and the opaque object is big, apparently what is going to be formed is what you call an umbra shadow. You're not going to have penumbra shadow. So this is what I mean by that now. We have source of light now, and we have, this is our object, and let's say this is our screen where the shadow will be cast. You see that when you look at this, and let's say this is source of light now, you see that, let's say we have this, we have this, and we have this. So let's put this down here. We have this. So you see that the shadow will be cast like this. Full shadow. This is going to be a full shadow that we're going to have here. We're going to have it. So look at our source of light. So we don't have what we call the penumbra region there. So apart from this umbra shadow, now we also have what we call the penumbra shadow. And what do you mean by the penumbra shadow? So for the penumbra shadow, penumbra shadow, what do you have under penumbra shadow now? Probably we have, so in penumbra shadow now, the source of light is partially blocked by the opaque. So this is when the source of light is partially what? Blocked by the opaque objects. So when it is partially blocked by the opaque object, it results in what you call penumbra region or shadow. And penumbra shadows are not as dark as umbra shadow. They are kind of grayish in color. So let's look at this now. We have, let's say we have source of light like this. We have our object like this, and let's say we have our source of light like this. We probably might be having, okay, I didn't get this properly. So let's say, okay, and what again do we have here? So we have something like this. So this is what we are going to have. We have one shadow here. We also have another shadow here. All of them on a screen. Now, first of all, you need to take note of one thing. This one that you have at your inner part. This one that is almost opposite, closer from this source. Look at, watch my hand. Please take look at my hand. So this one that is behind this opaque object, this opaque object, this shadow is called the umbra. But the other one that is at the end, just at the end, not behind it, just at the end, is known as what? The penumbra. It's called the penumbra. So this one is always dark, and the other ones are light. They are kind of grayish. They are not too dark. So these ones are not too dark. So you see that and here, because the opaque objects partially covered, blocked the source of light. it's blocked it, but it still casts a shadow. So if you look at it now, you can see some shadow around it, and that one is called your penumbra what? Your penumbra shadow. So that's it now. All right, now the next thing I'll go to talk about is what you call the eclipse. It's very important that you understand all these informations, because like I said before, your examiner will not ask you much question. The only thing they will keep asking is to understand whether you understood, to know if you understood the concept. And that is why they will twist the question. And if you understood the concept very, very well, anyway they twist the question, you can be able to, to answer them properly. For the eclipse, what do we have under the eclipse now? Well, when you talk about eclipse now, we are talking about whenever a heavenly body casts a shadow to another heavenly body, an eclipse is being formed. So eclipse are those shadows, or let's say now, yes, a kind of shadow that is formed on a body. Or okay, eclipse are just formed. Eclipse is formed when a heavenly body casts a shadow on another heavenly body. Yes, heavenly body. And when I say heavenly body, what heavenly body am I referring to? There are three that I'm going to be talking about in this topic now, and these are basically the sun. With just the heavenly bodies I'll be mentioning here are just the sun, the moon, and the earth. So these are the three that I'll be mentioning only. So under this eclipse now, we have to, first of all, we have what we call the solar eclipse. We have what we call the solar eclipse, or eclipse of the sun. Eclipse, or you can call it eclipse of the what? Of the sun, solar eclipse. And when you talk about solar eclipse is when you have the sun, and you have the moon at the middle, and you have the earth as the third. So when you have this kind of arrangement, it is called what? Solar eclipse. So you can use the word, you can use SME. SME, this is your solar eclipse, sun, moon, and earth. So when you have this kind of arrangement, it is called solar eclipse. But the other one, we also have what we call the lunar eclipse. We have what we call the lunar eclipse, or eclipse of the moon, or eclipse of the moon. So under eclipse of the moon now, what are we going to have now? We are going to have sun, we're going to have sun, we are going to have earth, and we are going to have moon. So whenever you have something like SEM, when you have SEM like this is what you call what now? Lunar eclipse. So one is SME. SME is your solar eclipse, and SEM is your lunar eclipse. So when the earth is in between the sun and the moon, it forms what you call the lunar eclipse. And when the moon is between the sun and the earth, it is called what? Your solar eclipse now. Now, we are expected to know some diagrams. I am going to draw this solar eclipse, and I'm also going to show you what we call the lunar eclipse. And at the same point, I'll also show you what we call, we have what we call total eclipse and partial eclipse, because it's very important you know about this, because your examiner might also twist a question coming in that sector, so that you know it very well. Now, let's talk about the first one, known as what? As solar eclipse. Solar eclipse. Solar eclipse is formed. Solar eclipse is formed when the earth, when the moon blocks the earth. Solar eclipse is formed when the sun, solar eclipse is formed when the sun is being blocked by the moon. So like I told you before, I told you that the moon is going to be at the middle, sun, moon, and earth. So when the moon blocks the sun from reaching the earth, it's called what we call the solar eclipse. So take note of that now. So whenever the moon blocks the sun, it is called solar eclipse. So let's look at the diagram, how it looks like. So we have this to be your sun. We have this to be your moon, and we also have this, let's take this smaller, and we also have this to be your earth. So let's look at this. Okay, so we have something like this. Let's say we have a diagram like this, and this is your sun, and here is your moon, and this one is your earth. Here is your earth. Please, I would like you to take note of one thing now. Okay, so this is what you call this, your solar eclipse now. So coming to this region now, this pointed place, this place is known as your umbra region. Here is known as your umbra region, umbra region. Whereas this place is known as your what? Penumbra region, penumbra region. Likewise, this place is what now? Your penumbra region, your penumbra what? Region. Okay. Then I would like you to take note of one thing now. At this umbra region now, what are we going to have here now? We are going to have what we call total eclipse. We are going to have a total eclipse. Then at this penumbra region, what are we going to have here? We're going to have what we call the partial eclipse. Partial eclipse. So likewise here, we're going to have what we call the partial eclipse. Partial eclipse. Then beyond this umbra and penumbra, so around here, all this place, we are going to have what? No eclipse. We won't have any eclipse here. So here is going to be what? No eclipse. Please take note of all this information, because the reason why I say you should take note of it is because your examiner can just do this. Now, please look at the way they present it now. Sometimes your examiner will always clean this one. We clean up this. And ask you, this region, what kind of eclipse are we going to have at this region? Remember that before you can say that it is under total eclipse, there must be an intersection. You must see something like this. There must be an intersection. That's why you now call it umbra region or total eclipse. But if you are not seeing something like that, you are just seeing something like this, no intersection. You're seeing something like that. Please, it's under penumbra region and it's under what they call your partial eclipse. Please take note of that. Don't confuse yourself. So be careful that whenever you don't see an intersection like that, it is under what you call your penumbra region, and that is penumbra region. So it's only when you now see this intersection, either it is like this or they all meet. You know, you must have a line that comes towards something like that. Either they meet or they have a little gap. You will now say that it's under the umbra region, and what you're going to see there is what you call your total eclipse. All right, now since we've done your solar eclipse, now the next eclipse we're going to talk about is what you call your lunar eclipse. Lunar eclipse. Lunar eclipse. Under your lunar eclipse now, what do you have now? This is also called the eclipse of the moon. Eclipse of the moon. Eclipse of the moon. Remember, how do I remember this? Same. Sun, earth, and moon. So let's have our diagram. We have our sun. Sun is always big. It's always the largest, sun. Then we also have your earth, followed by your earth, and then the moon is going to be the smallest. So we are going to have something like this. Okay. Sorry. All right. I think I got this one correctly. So that's it. So this is for this diagram. So coming to this now, this is our sun, and this is our earth, and this is our moon. This is our moon. You know, let's look at this is the path the moon is going to follow. A moon path. Okay, let's say moon orbit. The moon orbit. So let's call that one as your moon orbit. So at this point, so what are we going to have here now? At this point, what are we going to have at this point now? Here, you know, the moon is going to be dark. So we're going to have this region alone is our umbra region. This region is our umbra region. Then this region alone is umbra region. Then this region is our what? Penumbra region. Penumbra. Likewise, this region here, remember, this region is umbra, this region is penumbra, this region is what? Penumbra region. So let's look at this now. At the umbra region, we're going to have total eclipse. But I need you to take note of one thing. So, but here, you might be wondering that, what if the moon is here? Are we not going to have partial eclipse? No. At this point, if the moon is at the penumbra region, we are still going to have what we call no eclipse. We're going to have no eclipse. But however, what if it enters, it is between the penumbra region and umbra region? What if the moon is between the penumbra region and umbra region? What are we going to have? If it is between penumbra region and umbra region, we're going to have total eclipse. Sorry, we're going to have partial eclipse, sorry. We're going to have partial eclipse here. So we're going to have partial eclipse. And that is it. So coming to this one, that is for the moon's own. We're going to have, because it's between your umbra region and penumbra region, so we're going to have what they call your partial eclipse in that one. So that is exactly what we need to know. All right, now the last phase that we're going to be talking about is what you call your pinhole camera. So I need to explain the things that you need to know about your pinhole camera. So just take note of this. Please stay to the end of this video so that you grab all the... So for the pinhole camera, what do we need to know about pinhole camera? This is our pinhole camera. What do we need to know about our pinhole camera? So this is our pinhole camera. Let's have a sketch of it. Okay. So we have an object here. So we are going to have, here is going to be our screen. So we have something like this. So depending. And the image is going to be what? Inverted. So this is our pinhole camera. So what do we need to know about it now? You need to form. So images, let's talk about it called the images. Images formed by pinhole camera. Pinhole camera. Images formed by pinhole camera. Now let's consider the images formed by pinhole camera. Number one, now if it is with pinhole, with pinhole, that is, the hole is very small. If the hole is very small, that is with pinhole. What happened now? The image is formed. Image will be what? Image is sharp. Image is sharp. Sorry, sharp. Image is sharp, clear, and dim due to limited light, due to limited amount of light, due to limited amount of light passing. Take note of that. So if you have it, if the hole is very small, what happens now? The image that will be formed will be what? Will be sharp. It will also be clear, and also be what? Will be dim. If the hole is very small, that is when you say the pinhole. What if the hole is large? With large hole. So what about the large hole? What of large hole? If the hole is large, what happens to the image now? The image is blurred. Image is blurred. Overlapping. The image will overlap each other. Overlapping. And bright. The image will also be what? Will be bright, but it won't be sharp. Okay? So it simply means that the brightness of the image is inversely proportional to the sharpness. So to the sharpness. So if the image is sharp, it will not be what? It will be dim. It won't be bright. But if it is bright, it will not be what? It will not be sharp. So that is exactly what it's trying to make us understand. Then another thing that you need to take note of is this. It's under magnification. So for large magnification, object distance must be very small. For large magnification, when you talk about magnification, the magnification can be large or small. You want to, depending on how you want to go about it. So for large magnification, what happened now? Object distance must be very, very what? Very small. The object distance must be very small. So if we want to get our large magnification, what happen now? The object distance be what? Will be very small. So it just simply means that your image distance, your image height is directly proportional to your what? To your object distance. So if the object, is directly proportional to your image distance and inversely proportional to your object distance, Object distance. Someone might be wondering, how did I know, or you don't understand what that? Let me explain further how I mean by that now. If you place this image closer to this pinhole camera, the image form will be what? Will be large. But if you place it far away, it's going to be the reverse. Likewise, another point that you need to take note of is this now. If you increase the length of this camera, what happens now? The image form will also be what? Will be large. Let me show you how I knew. So look at this now. The formula for magnification. Magnification is given as what now? Is given as is equal to what now? Image height, all over what? Object height. Object height is equal to what? Image distance, all over what? Object's distance is still equal to length of camera, all over what? Object's distance, distance. So what does it mean now? If you want to get higher magnification, that is, if you want to get larger height, larger image, what happens now? The image distance must be what? Must be big as well. So if you increase the length of this camera, what happens now? The image is going to be what? Will be larger. But at the same time, there's one other rule that you need to keep. If you want to increase the image height size, it is either called image height or image size. If you want to increase the image size, now make sure that the image distance is increased, or the length of camera is increased, so which is you have to increase it, or you do another thing, which is you decrease the object height, or you decrease the object distance. Let's say you decrease the object distance. If you decrease the object distance, that is, you place this object closer to the camera, that is when you now get the what? The height or the image to be what? To be larger. All right, now, so in the next class, we're going to be performing some calculations under this pinhole camera. So this is going to be in my next episode. Now, to avoid missing that, and if you are new to this channel, please subscribe and also click on the notification bell icon if you really enjoyed what we did today. All right, I'm going to see you in my next episode. Thank you.